Pluto, an isolated and somewhat mysterious celestial object, was once categorized as part of our immediate planetary system. However, recent bold statements by renowned astrophysicists like Neil deGrasse Tyson and Michio Kaku have sparked renewed debates about Pluto's classification. These experts have speculated that this cold, distant dwarf planet may be on a trajectory toward a potential collision with Neptune. But how could such a rare event happen? And what would the consequences of such an immense crash be? Could this be an example of unpredictable cosmic behavior? Or is there a more significant underlying factor involved? Join us as we investigate the possible outcomes of a Pluto-Neptune collision. Once classified as a planet, Pluto was later redefined as a dwarf planet, but it continues to capture the imagination of astronomers and space enthusiasts. Leading scientists have recently voiced concerns regarding Pluto's proximity to Neptune, suggesting that a disastrous collision may not be out of the question. But just how plausible is this theory? Pluto's orbit around the Sun is unlike that of any other planet in the solar system. It takes an extraordinary 248 years to complete a single orbit, and since its discovery in 1930, it has yet to finish a full revolution. However, Pluto's orbit is not defined solely by its long duration. It is highly elliptical, causing it to travel much farther from the Sun than the major planets. One of the most striking aspects of Pluto's orbit is its considerable tilt of around 17 degrees off the plane of the solar system, resulting in a more erratic trajectory compared to the other planets. Even more remarkable is the overlap between Pluto's orbit and Neptune's. For about 20 years during each orbit, Pluto actually comes closer to the Sun than Neptune. This raises an important question. Why hasn't a collision occurred between the two? The answer lies in the gravitational interactions between various planets, particularly those in the outer solar system. When Pluto was first discovered, astronomers quickly noted that its orbit was dramatically different from the more circular orbits of the other planets. Pluto's irregular, highly inclined orbit puzzled early scientists, and further research revealed that its path indeed intersects with Neptune's. Despite the apparent chaos of their respective trajectories, Pluto's orbit remains stable, preventing a collision. This stability is due to a complex interaction of gravitational forces, often referred to as the three-body problem, which predicts how three celestial bodies such as Pluto, Neptune, and the Sun influence each other's movements due to their mutual gravitational attraction. One primary reason Pluto and Neptune do not collide is a phenomenon known as non-concurrent libration. This means that whenever Pluto crosses Neptune's orbit, it is always at least 90 degrees away from Neptune, ensuring that their paths do not intersect. Another vital factor is orbital precession, which refers to the shifting of a planet's orbit in a vertical direction. In Pluto's case, its orbit changes in such a way that it avoids Neptune's path by staying either above or below Neptune's orbital plane. A third significant component is the VSK wobbling effect, named after three researchers who analyzed the gravitational influence of multiple celestial bodies. This wobbling effect illustrates how the Sun, Neptune, and Pluto's gravitational forces interact to maintain a stable orbital configuration, even despite Pluto's erratic orbit. This wobbling motion helps keep Pluto's orbit stable over long time periods. In the late 1980s, numerical simulations showed that while Pluto's orbit may seem chaotic, small changes in its initial conditions could lead to different trajectories over time. However, despite this unpredictability, simulations indicated that Pluto's orbit remains stable over vast timescales, largely due to the gravitational influence of giant planets such as Neptune, Jupiter, and Saturn, which play essential roles in preserving this stability. Interestingly, Pluto's orbit exists in a special resonance with Neptune. For every 2 orbits Pluto completes, Neptune completes 3. This gravitational relationship creates a lock that ensures that even though Pluto's orbit intersects Neptune's, a collision is impossible. This resonance serves as an additional safeguard, preventing Pluto from entering Neptune's path. Jupiter's enormous gravitational pull also plays a crucial role in stabilizing Pluto's orbit. Jupiter's powerful gravity helps keep Pluto on its relatively steady course, with additional support from Saturn. As a result, the likelihood of a catastrophic collision between Pluto and Neptune seems extremely low. These factors contribute to the extraordinary stability of the solar system, ensuring that Pluto stays on its designated trajectory. Yet, despite these stabilizing forces, the future of Pluto's orbit is not guaranteed. The outer solar system is in a constant state of flux, and even small shifts in the positions or velocities of the planets could disrupt the delicate balance currently in place. External forces, such as the gravitational pull of an undiscovered planet or a passing star, or internal factors like tidal forces, could potentially alter the orbits of Pluto and Neptune, leading to unforeseen consequences. The relationship between Pluto and Neptune is far from fixed. While current research suggests a collision is highly unlikely, changes in the outer solar system could upset this balance. This serves as a reminder of the dynamic nature of the cosmos, where even stable systems can evolve over time. Leading astrophysicists like Neil deGrasse Tyson have offered insights into the future of Pluto's orbit, emphasizing the ongoing mystery and complexity of celestial mechanics. Tyson, who played a key role in Pluto's reclassification as a dwarf planet, views the study of planetary systems as an ongoing journey of discovery. He sees the evolving understanding of planetary dynamics, such as Pluto's interactions with Neptune, as a means to gain deeper knowledge of the universe. Tyson's perspective on Pluto's future highlights the unpredictability of space. While he acknowledges the stabilizing forces at play, he also cautions that dramatic changes in Pluto's orbit could still occur. Will Pluto eventually collide with Neptune? Or is this just another cosmic mystery yet to be solved? Only time will tell. Despite the complexities of their orbits, Pluto and Neptune continue to captivate the scientific community. The potential for a catastrophic event involving these two planets raises important questions about the mechanics of celestial systems and the forces that govern our solar system. Understanding these dynamics offers valuable insights into how the planets and other bodies interact and how even the smallest changes in one part of the system can create far-reaching effects. While the prospect of a Pluto-Neptune collision remains a fascinating topic of interest, the intricate gravitational relationships between the two planets, along with the stabilizing influences of Jupiter and Saturn, make such an event seem highly improbable. As scientists continue to study the movements of these planets, they refine their models and work to uncover the solar system's mysteries. With advancements in technology and constant observation, we may gain a better understanding of the forces preventing Pluto from crashing into Neptune, or perhaps discover new variables that could alter everything. While the possibility of a catastrophic Pluto-Neptune collision continues to intrigue astrophysicists, it is crucial to delve deeper into the complex mechanisms that maintain the stability of their orbits. The gravitational resonance between Pluto and Neptune, which locks their orbits into a stable pattern, serves as a significant safeguard against any potential impact. This celestial dance ensures that, although their orbits intersect, the two planets never come dangerously close to each other. This mechanism highlights the precision and complexity with which the universe operates, showing how even seemingly erratic paths of distant planets can exist in perfect harmony. The importance of understanding these gravitational interactions becomes even clearer when considering the role of other massive planets like Jupiter and Saturn. Jupiter's gravitational pull, the strongest of any planet in the solar system, plays a pivotal role in preventing Pluto from veering too far off its path. Without this stabilizing influence, Pluto's orbit might become even more erratic, increasing the likelihood of a collision with Neptune. Saturn's gravity also contributes to the cosmic equilibrium, further reinforcing Pluto's place in the outer solar system. Together, these gravitational forces create a finely tuned system that prevents dramatic events like a collision between Pluto and Neptune from happening. However, this delicate balance is not impervious to change. Over vast time periods, the positions and velocities of celestial bodies can shift, making orbital precession an important concept. Small, gradual changes in planetary orbits and moons can accumulate, potentially altering the dynamics of the solar system. These shifts could be triggered by external influences, like the gravitational pull of a passing star, or by internal factors such as the slow decay of orbits due to tidal effects. While the solar system is currently stable, scientists recognize the potential for long-term changes. As technology continues to advance, astronomers will improve their models and observations, enhancing our ability to predict potential shifts in the outer solar system's orbital dynamics. The study of Pluto, Neptune, and their interactions offers a prime example of how scientific inquiry evolves. Initially, Pluto was simply regarded as another planet in the solar system. But through careful observation and analysis, scientists have come to appreciate the complexity of its orbit and its relationship with Neptune. This evolution in understanding highlights the ongoing nature of scientific discovery, where new insights and advancements continually reshape our view of the universe. As we continue to investigate the intricacies of Pluto and Neptune's relationship, it becomes clear that the dynamic between these two distant bodies is not just an academic curiosity. It provides crucial insights into the broader mechanics of the solar system. The stable orbital paths of these planets, maintained by a delicate balance of gravitational forces, highlight how systems that seem chaotic on the surface can often be governed by underlying rules and patterns that are not immediately obvious. This observation serves as a reminder of the complexity of the universe, where every interaction, no matter how small or seemingly insignificant, can have profound consequences on the larger system. The study of Pluto and Neptune also underscores the importance of precision in astronomical measurements. Even the smallest variations in the gravitational influences exerted by distant planets can alter the trajectories of celestial bodies, affecting their long-term stability. It is only through the continuous collection of data and the development of more accurate observational tools that we can hope to understand the true nature of these interactions. Moreover, these discoveries help deepen our understanding of the forces at play in the outer reaches of our solar system, where the gravitational pull of large planets like Jupiter and Saturn continues to play a vital role in maintaining the overall structure of the system. In the future, as our observational capabilities improve and our understanding of planetary dynamics evolves, we may uncover new factors that could influence the interactions between Pluto and Neptune, or perhaps reveal previously unknown aspects of their orbits. For example, the potential discovery of a new planet or a passing star could exert gravitational influences on these two distant bodies, potentially altering their trajectories in unexpected ways. Similarly, internal factors such as the gradual decay of planetary orbits due to tidal forces could also introduce new risks or lead to unexpected changes in the system. The continual study of Pluto, Neptune, and the other celestial bodies in the outer solar system will be essential in keeping track of these potential shifts, allowing astronomers to predict any future changes in their orbits. The case of Pluto and Neptune is also an important lesson in the ongoing nature of scientific inquiry. As our technology improves, we are better able to track and study the movements of celestial bodies over long periods, allowing for a more nuanced understanding of their behavior. This evolving understanding not only helps us predict the future paths of planets but also sheds light on the underlying principles that govern the motions of objects in space. The possibility of a collision between Pluto and Neptune, while unlikely, continues to captivate scientists because it serves as a reminder of the delicate balance that exists within the solar system. Despite the stability that exists in their orbits today, the future of these planets is not entirely predictable. The solar system is a constantly changing environment, and even small shifts in the positions or velocities of its members can have far-reaching consequences. This dynamic nature is why the study of planetary systems is so important. It reminds us that while we may have a relatively stable view of the cosmos at the moment, this stability could be disrupted at any time. As our knowledge of space and our ability to observe and model celestial bodies continues to grow, we may be able to better understand these disruptions and predict their potential effects. The relationship between Pluto and Neptune is just one example of how seemingly small changes in the gravitational forces within the solar system can lead to significant consequences. As we continue to explore the complexities of these interactions, we also uncover new insights into the stability and evolution of the solar system as a whole. Understanding these dynamics not only helps us predict the future of individual planets, but also provides a deeper understanding of the forces that govern all of space. This ongoing exploration is a testament to the power of scientific inquiry and the potential for discovery in even the most remote corners of our solar system. Ultimately, the study of Pluto and Neptune reminds us of the vastness of the universe and the infinite possibilities for discovery that still lie ahead. With each new finding, we gain a deeper understanding of the forces that shape our solar system and the complex interactions that maintain its delicate balance. Although the possibility of a Pluto-Neptune collision remains unlikely, it is through the study of these unlikely scenarios that we gain invaluable knowledge about the cosmos. In this way, even the smallest changes in our understanding can have profound implications for our view of the universe and our place within it. As we continue to observe the motions of Pluto, Neptune, and other distant celestial bodies, we are reminded of the dynamic and ever-evolving nature of space. The potential for change, whether due to external forces or internal dynamics, serves as a reminder of the need for continuous observation and research. Only by staying vigilant and continuing to refine our models of planetary motion can we hope to fully understand the complexities of the solar system and the universe beyond. The case of Pluto and Neptune provides a fascinating glimpse into the intricate relationships that govern the behavior of the planets and reminds us of the beauty and complexity of the cosmos, which continues to reveal its mysteries to those who seek to understand it. In conclusion, the potential for a Pluto-Neptune collision, while unlikely, serves as a powerful example of the unpredictable nature of space. It highlights the complexity of celestial mechanics and the delicate balance that exists between the planets. The gravitational forces at play between Pluto, Neptune, and the other giant planets in the outer solar system work together to prevent a catastrophic event, but the ever-changing nature of the cosmos ensures that this balance is never guaranteed. As our technology and understanding of planetary systems continue to advance, we will undoubtedly uncover even more about the forces that shape our solar system and the potential risks that exist within it. The study of Pluto, Neptune, and their interactions offers valuable insights into the forces that govern planetary motion and the stability of our solar system. It reminds us that, although we may have a relatively stable view of the universe at the moment, the cosmos is always changing, and there is still much more to discover.